In this tutorial we will see how to use cuRobo with Custom Robot Arm. cuRobo is a CUDA-accelerated library containing various robotics algorithms that run significantly faster than existing implementations leveraging parallel computing. We will execute target following using our own robot. Firstly, we have to design our own robotic arm. This time, I used Autodesk Fusion, but you can use whatever CAD software you want. In this tutorial I will not explain how to operate Autodesk Fusion itself, but there are some tutorials and documents in the internet. For this video I designed this robotic arm. It has 6 degrees of freedom and uses 8 Dynamixel X18 servos. But X12 servos can be used as well. For most of the brackets, FP04 series are used, but some are originally designed. Since drawing every part is time-consuming, if there are publicly available CAD files, I recommend to use them. For example, in case of robotics products there are CAD files available for almost all products. If you design your robotic arm for manipulation, it is good practice to set origin of the end effector at the point where you assume that the gripper will hold the object. After mechanical design of the robotic arm is complete, we have to create a Zacro file. In this tutorial I provide all files that are required for the simulation, so please download them from the Google Drive. The structure of Zacro file is straightforward. We just have to connect each part one by one. Since structure of almost all robotic arms is similar, I recommend to have a base file which can be modified. Translation distance of each arm can be measured in CAD. For rotation, set initial angle according to initial pose of the arm that will suit your use case. After creating a Zacro file, build this package using the build command. Then convert the Zacro file into URDF file. Now we are going to install cuRobo. Move to the cuRobo page. Installation procedure as described in the Get Started section. First, install Git LFS. Git LFS is an extension for Git that manages large files more efficiently. Clone the cuRobo repository. In this tutorial, we will install cuRobo to a virtual environment which already has IsaacSim 4.5 installed. If you have not installed IsaacSim yet, please see NVIDIA documentation. Installation is simple. Move to the cuRobo repository and execute pip install command. Now, CUDA version does not have to be necessarily 11.8 like written here. In this tutorial, we are using CUDA version 12.4 and it works fine. We have to do several things to use Custom Robotic Arm with cuRobo. Firstly, we have to create a description of our arm. For that, move to the robot directory which is located inside the assets directory. Here, create Custom Arm Description directory. Then, move here the URDF file that we previously created and the whole meshes directory. Now launch IsaacSim. Open the URDF file we just moved. Close Isaac Sim. We don't have to save. The USD file will be created inside the custom ARM directory. As the second step, move to the robot directory inside the configs directory. Here we have to create robot configuration YAML file for our robot. There is a template YAML file in this directory, so we can copy and fill necessary parts. But in this tutorial, I prepared the file for our robot. Just copy it and paste in this directory. In these two lines, we define location of the USD file of our robot. In this part, location of the URDF file is defined. Under collision link names, the links that we want to take into account for collision calculation are listed. Here, name of the file which includes collision sphere information is defined. We will create this file in a moment. In this part, for each link, names of the link's collision with which we don't want to consider are defined in array form. So, for example, for the wrist link, collision with the gripper link and finger link will be ignored. Here, name of the links which have mesh files are listed. Under the C-space tag, in the joint names array names of each joint are listed. Leave the rest as it is. Note that number of indices in these arrays should be the same with the joint names array. We needed to do one more thing. Currobo uses spheres for collision calculation. So, we have to create a file in which sphere information is defined. Open Isaac Sim. Open the USD file of our robotic arm. From the Tools bar select Robotics, Lula Robot Description Editor. Click Play. From the selection panel select Custom Arm and Shoulder Link. From the Set Joint Properties menu, set joint status of all joints to active joint. Select Add Sphere menu. Click the Add Sphere button. A collision sphere will be added. After the collision sphere is generated, we can move it and modify its radius. Generate collision spheres for all links. In our case, it will look like this. Select Export to File. Select Export to Lula Robot Description File. Save this file. We are not done yet. Copy the generated file and move it into the spheres directory. Change extension to YML. Open this file. Remove hyphen on the left side of each joint name. This is done to avoid error when Currobo reads this file. Note that for the Lula Robot Description Editor we should use the original format. We are ready to run the code. This code is a modified version of the original Motion Gen Reacher script. I modified values of some default arguments. Change names of the libraries to those of Isaac Sim 4.5. Add a function to set initial position and orientation of the robot. And other small modifications so that this code runs smoothly. Move this script and the helper py script into the Isaac Sim directory. Now open virtual environment and execute this code. After the robotic arm appears, click the play button. When you move the target cube, the arm will follow it.